Hi, this is Mrs. Myers, and we are going to be learning how to simplify radicals today in the most basic form. Okay. First of all, remember what square roots mean. R is a square root if the number s of a number s, if r squared is s. In other words, r squared equals s, therefore the square root of s equals r. This sounds like a lot of mumbo jumbo, but remember the square root of 16 is 4 because 4 squared is 16. 4 squared means 4 times 4, times itself, in other words, is 16. So if you have a variable like x squared equals 25, you're thinking, well, what's this x then? Well, if x squared is 25, then x is the square root of 25, which is 5. Now, in this case, it could also be negative 5, right? Because negative 5 times itself is also positive 25. So we'll talk about that at some point. But right now, we just want to learn how to simplify the radicals. This is just a bit of vocabulary. The radical is this whole thing. A radical sign is just this symbol that you'll see, and you can see it on your calculator. And a radicand is the number that's under the radical sign. So in my problem here, the radicand was 25. All right, there are some properties of square roots, product property and quotient property. The product property says that if you have two numbers that are both under square root signs, like the square root of 3, and you multiply it, product means multiplication, multiply it by the square root of 5, you can actually multiply these numbers and then get the square root of 15. So if you think about that in reverse, if you have a big number like the square root of 27, you can write that in a broken down form, like the square root of 9 times the square root of 3. Okay, so the product property is going to help us with simplifying radicals in a minute. Because of this property, square root of 3 times square root of 5 equals the square root of 15. As a property, we would write it like this: the square root of x times the square root of y equals the square root of xy, the product of those two numbers. Quotient property is a similar idea. It says if you have the square root of, let's say, 3 over the square root of 5, you can write that as the square root of 3 over 5 with one big radical sign and combining the numbers as one fraction underneath. This is helpful if you have a problem like this, square root of 8 over the square root of 2. Well, if we could write that as the square root of 8 over 2, that makes our life a lot easier, because here, the square root of 8, that would be a decimal. Square root of 2, that would be a decimal. But when we make it the square root of 8 over 2, 8 over 2 is just 4. Well, the square root of 4 is 2. So that helped us to simplify. Now, there is one basic thing that we have to keep asking ourselves when we are trying to simplify square roots. We're asking ourselves this question: does the number under the radical sign, in other words, the radicand, does that number under the radical sign have any perfect square factors? Now, in order to know what that question that we're asking ourselves means, we have to know what perfect square numbers are. Well, perfect square numbers are numbers where, when we take the square root of them, we get a whole number. So, for example, 4 is a perfect square number because the square root of 4 is 2. 9 is a perfect square number because the square root of 9 is 3. So to make this list, we could think to ourselves, 2 times itself is 4. 3 times itself is 9. 4 times itself is 16. 5 times itself is 25. Keep going with this list. Okay, did you get some more on there? Keep going. You should have 36. That's 6 times itself. 7 times itself is 49. 8 times itself, 64. 9 times itself, 81. 10 times itself, 100. And that's all I asked for, through 100. We could keep going, but that's all I asked for. Okay, we are going to use those perfect square numbers when we are simplifying radicals. So here we have, oh gosh, the bell's about to ring. This is bad. We're going to simplify this square root. Look at 54. Think to yourself, what two numbers can be multiplied together to make 54, where one of the numbers is from this list? So we're asking ourselves, is there a perfect square number from this list that goes into 54? So you should think to yourself, aha, 9 goes into 54. How many times does 9 go into 54? 6 times. So you can rewrite the square root of 54 as the square root of 9 times the square root of 6. The square root of 9 is a perfect square, so we can simplify that to 3. Okay, so our final simplified answer here is 3 times the square root of 6. So the square root of 54 equals 3 times the square root of 6. They are equivalent. That is the simplified version of that answer, square root of 54. Let's try number 2. Again, asking ourselves, is there a perfect square number from this list that goes into 50? Well, 4 doesn't, 9 doesn't. You want the biggest one possible too. So 25 does go into 50 2 times. 25 is a perfect square. So the square root of 50 equals the square root of 25 times the square root of 2. And the square root of 25 can be simplified as just 5. And then the square root of 2 stays the square root of 2. Now, how do we know we're done simplifying? Because we keep asking ourselves, remember, keep asking ourselves, does the number under the radical sign have any perfect square factors? Well, does 2 have any perfect square factors? Do any of these numbers go into 2? No. So that's how you know you're done. 6, same thing. Do any of those numbers go into 6? No. So you know you're done. Let's try square root of 48. The square root of 48 can be simplified. Well, you want the biggest one possible, but maybe the biggest one doesn't pop into your head right away. So when I look at 48, I know that 4 goes into 48, and it goes in 12 times. So now I'm going to simplify. 4 is a perfect square, so the square root of 4, I'm going to make that equal to 2. The square root of 4 is 2. And so I have 2 times the square root of 12. But remember, I have to ask myself, are there any perfect square factors that go into the number under the radical sign? Looks like I do have some. 4 goes into 12 as well. So now I have to break down 12 further. I'm going to keep this 2 that I already simplified. I'm going to keep it as a 2. And then I'm going to rewrite the square root of 12 as the square root of 4 and the square root of 3. 4 being the perfect square from this list that goes into 12. Well, the square root of 4 I can simplify as 2. I already have my 2 from before. All of these get multiplied together. So my final answer here is 2 times 2 is 4 times the square root of 3, and that's my final answer. Because now I'm asking myself, does 3 have any perfect square factors? And the answer is no, it does not. So I'd like you to pause the video now and try some of these last 3 on your own, and then come back and check your answers. Okay, so here you can see the work that I've done to solve and simplify. Final answers are here. For this one, just notice that there was a 5 out front to begin with. That's okay. You just leave it as a 5 and simplify the radical. And then remember, you're multiplying everything at the end. This is just a little note about exact form. When you leave your answer as a simplified radical, it's considered the exact form of your answer. Okay, thank you. We'll talk about this more in class tomorrow.